Greetings, J-Chem fam. We are going into limiting reactants, and this is our worksheet number 1 practice. So we have a general foundation for what limiting reactants are. Remember, it's the first reactant that runs out, meaning if you have more than one thing coming together and reacting, eventually one of them is going to run out. The first one that runs out stops the reaction, and therefore the one that runs out determines how much product is going to be formed. So let's actually figure it out. So if we have this problem, it says if you have 4.1 grams of chromium, right, and it's heated with 9.3 grams of chlorine, we want to know what mass of chromium chloride is produced. Okay, so first thing we have to do is write a balanced equation because we're going to need the coefficients for our stoichiometry. So if chromium is heated with chlorine, it reacts and it's going to form chromium chloride. Man, I've been saying that wrong, I bet the whole video. Sorry about that. All right, let's take a look and balance this bad boy out. I have 2 chlorines over here and 3 over here, so I'm going to need to make them both 6. So I'm going to drop a 2 and a 3. That's going to give me 6 chlorine on both sides. That's also going to give me 2 chromium. So I'm going to put a chromium there. All right? So now that we've balanced our equation, which is good, we need to start thinking about what is our limiting reactant. To do that, we're just going to take our 2 reactants, 4.1 and 9.3, and we're going to convert them into the product. Why? Because whichever reactant runs out first will create the lowest amount of product. Therefore, we'll figure out what the limiting reactant is, what ran out first, and also exactly how much product was made at the very end. So let's do it. It's just 2 stoichiometry problems. All right, let's start with chromium. If I have 4.1 chromium, sorry, that's grams of chromium, I'm going to want to eventually convert this so that I know how many grams of chromium chloride I've made. So CrCl3, right? And again, I'm setting it equal to grams of the product so I can figure out which of the reactants made the lowest amount. All right? I can also do that with my other reactant, which is 9.3 grams of chlorine gas. All right? I know it's going to be a 3-step stoichiometry problem. Why? Because I'm going to go from mass A island to mass B island. So I'm going to end up solving for the same thing. Once we get the answer for both of them, we can compare and take whichever one is the lowest amount. That's the one we know actually is producing the proper amount because we'll know what the limiting reactant is. All right, so let's start with the top equation here. I have 4.1 grams of chromium, and I'm going to convert that to moles of chromium. To do that, I'm going to divide by the molar mass. If you look on the periodic table, chromium is 52 grams, and that's going to be under 1 mole of chromium. Now that my grams of chromium have canceled, I'm left with moles of chromium, and I'm going to have to convert my moles of chromium into my moles of my product. So I'm going to put A moles on the bottom, which is what I started with. So according to the balanced equation, I have 2 moles of chromium. All right, so I'll write that down on the bottom for every 2 moles of chromium chloride. So I'm going to put 2 moles of chromium chloride. All right, what that did was cancel out my moles of chromium, and I'm left with moles of chromium chloride. Now the last thing I need to do is just convert my moles of chromium chloride into the mass of chromium chloride. So I'm going to put 1 mole of chromium chloride on the bottom. That's normal according to our mole map because I'm going from moles of B to mass of B. And then on top I'm going to put the mass of chromium chloride, which is 1 chromium plus the 3 chlorines. Add all of those up and you get 158.35 grams of chromium chloride. All right? Now, remember, when I do the math, I'm going to multiply by the tops, so 4.1 times 1 divided by 52 times 2 divided by 2 times 158.35 divided by 1. You always multiply by the top and divide by the bottom. The answer you end up getting is about 12.49 grams of chromium chloride. Okay? Now, we can't do anything with that until we figure it out from the other reactant to see which runs out first. So, we're going to start with mass of A, and we're going to go to moles of A. So, I'm going to divide by the molar mass, which is about 70.9 grams for 2 chlorines. I got that off the periodic table. I'm going to put it over 1 mole of chlorine gas. Now, from the the balanced equation, there's 3 moles of chlorine for every 2 moles of chromium chloride. So on the bottom, I'm going to put my 3 moles of chlorine, Cl2, good old Brinkelhoff, for every 2 moles of chromium chloride, CrCl3. Okay, now that I did that, let's double check. Grams of chlorine cancel, moles of chlorine cancel. I'm left with moles of chromium chloride. Last thing I'm going to do, just like in the step up here, I'm going to take 1 mole of chromium chloride, and I know that it's 158.35 grams of chromium chloride. Again, I found that number by adding up 1 chromium plus 3 chlorines. Again, you want to multiply the top. So 9.3 times 1, divide by the bottom, divided by 70.9, times 2, divided by 3, times 158.35, divided by 1. When we do that, we end up getting an answer of 13.85 grams. Okay, now's the time where we get to answer our question. If we used up all chromium, we would end up with 12.49 grams of chromium chloride. If we used up all the chlorine, we'd end up with 13.85 grams. Since 12.49 is less, we know this is the true amount of chromium chloride that would form. So we would say that 12.49 grams of chromium chloride would form. All right? And that's because it's the less amount that you take. Now, why do you take the lesser amount? It's because whichever reactant created the least amount, in this case, it was chromium. Chromium then becomes your limiting reactant. So you could say chromium is our limiting reactant, or LR for limiting reactant. What you could also say then is that we have excess chlorine, meaning we have extra chlorine gas. It isn't all used up because the chromium is used first. All right? But in the end, we did an entire problem and we figured out that chromium runs out first. It's our limiting reactant, and therefore the only amount of product that would form would be 12.49 grams of chromium chloride. Okay? Hope this step-by-step helped you out and gave you a little clearer picture of how we figure out limiting reactants, what limiting reactants really are, and why a limiting reactant help predicts the product. Take care, JChem. Much love.